this, and then I'll let Sarah share her knowledge. So, welcome everyone to the Uber technical interview question, led by Sarah, who is a software engineer at Uber and an alumni of Outco. Um, so, just an overview, as Monica has mentioned, just kind of introducing you to Sarah, what the Uber technical interview will be, and then we will have time for Q&A at the end. Sarah, I don't know how you want to do Q&A this time.
We can wait until the end of the question so I can answer both the technical and non-technical question at the same time.
Perfect. I wanted to introduce Outco. So Outco is career accelerator for software engineers. We were founded in 2015, and we focus on helping software engineers through their technical interview process by coaching and sharpening their skills. One of our coaches is Sara, who helps you go through the technical interview process. We've helped over 2,000 job searching engineers, and we have classes in East Coast and Pacific Standard Zone. I'll share with you on the chat if you want to join one of our info sessions, or we have other events coming up, so I'll share on the chat links. And if you're interested in learning more about Outco, let me know. Perfect. And then my name is Patty Montoya, as you saw. And then Sara, if you don't mind introducing yourself.
Hey guys, my name is Sara. I'm a software engineer in the privacy and infosec team at Uber. I'm also a teacher at Outco. Before Outco, I was not before Outco actually. During Outco and before Uber, I was a software engineer at Okta. Okta is a identity and access management company. So I've been at Uber for about 11 months. It seems insane, but because I just feel like I've been here 2 months, but it is what it is. Right. Let's see what's next. Should we go to the question?
Yeah, we're ready to start.
All right. Thank you so much for coming. I appreciate it. You guys need to send, most of you guys have done it. Can you guys please write your location, the city you guys are joining in the chat? I would like to know. Just write, for example, San Francisco or some wherever you guys are from. I live permanently in San Francisco, but currently I am in Lahore, Pakistan. So it is 7:30 in the morning. And last night I worked, so we almost had an accident this morning with me not showing up in the session, but gladly I was able to come. So and I'm happy to be here. Thanks for coming, for you guys as well. SF, Oakland, Miss area. Houston. Okay. All right. So let's start. You guys could keep adding your city, and then I will keep. I will start presenting. Okay. So a little bit about my background in interview. When I was at Okta, I was interviewing students, and then obviously when I went to Okta or when I went to Uber, I interviewed among all companies, most companies, like 20, 30 companies, and including all the fun companies. I have also been interviewee and interviewer, in addition to my experience at teaching at Outco. I've been a student at Outco where I've learned about the process of how to interview, and also a teacher on the process of how to assess an interview and things like that in terms of soft skills and hard skills. So please feel free to ask any other questions you guys have in the QA at the end. Right now, I'm going to kind of like change my roles as a interviewee and interviewer. So if you feel like there is some questions that you guys have, please feel free to put it in the chat. I will see if I can keep the chat open so I can remember. I can look at it while I'm interviewing. For now, let me open the. Okay. Okay. So this is, yeah, I can see you guys' chat. It's open here. So feel free to say whatever you guys would say. Usually people catch a lot of my syntax mistakes, so that's really helpful. Additionally, if you guys have the link, please, if you select it, unselect it, because it will bother everybody else if you select it and it will just show because it's an IDE that's collaborative, right? Okay, so the question that I have is this. Okay. For this test, you will be given elements of a perfect binary tree of character stored within the simple tree data structure. Your goal is to write a function that starts at the root of the tree and returns a counterclockwise traversal of the nodes at the edge of the tree. So for this task, you will be given elements of a perfect binary tree of characters stored within a simple data structure. Okay, so we will have a perfect binary tree, whatever that means, and it is inside a tree data structure. Your goal is to write a function that stores at that starts at the root of the tree and returns a counterclockwise traversal of the node at the edge of the tree. Okay. So given this, can you guys add a plus if you guys have seen this problem before and solved it? Squiggly line if you guys have seen this problem but haven't signed it, and then a minus if you guys haven't seen it or solved it in our chat, please. Never seen it. This is good because you guys are going to get a lot out of this problem. Nice. Nice. Nice, nice, nice. Okay. I have not seen anybody in the chat that says they have seen it or solved it. So that's very good because all of us will get value out of it. Okay. So as soon as I see this question, as an interviewer, when I give this question, I totally expect the interviewee to ask me questions. So as soon as I see this question as an interviewee, what I'm going to do is I'm going to go to the same basic structure I have. Usually when you see the question, you don't understand it or you don't know how to solve it. So if you don't have a structure, you kind of get lost and you're like, oh my gosh, I'm gonna fail, especially if you have not seen that question. So that's why I have a very simple structure that I will always follow, no matter if I know the question or not know the question. And that is 4-step structure. Okay. The first one is understanding the problem. Okay. The second one is the diagramming. Okay. Diagramming. The third one is pseudocode. And then the last one is code. Okay, so at each one of them, I will go step by step and see how it goes. Okay, for understanding, what we need to do is you ask for input and output, and also you define your input and out. Okay, so that would be IO, input and output. Then let's define some constraints. Okay, see what things that I would miss and things like that. So let's figure that out first, and then we'll go to the next step. Once I get that and I read it and I understood it, I'm going to ask my interviewer, would you be able to give me some information about some input? Give me an input. And then your interviewer is going to give you an input. Okay, so let me see. I'm going to write the input at the top. Okay. So they're going to give you something like this, and you're going to be like, okay, this is kind of confusing because I don't understand it, right? And when you hit that situation, you're gonna you want to make sure that you understand the input. Okay. For me, how I understand, I would understand this a lot of gibberish and a lot of line is to diagram it. Okay, always diagram. And if I diagram this tree data structure, it looks something simpler, and I would understand it better. So let's look at. I'm gonna write this here. Okay. Okay. So I'm still in the phase one, okay, which is understanding. I just want to understand the output better, okay, so the input better. And when I translate this guy over to the UI or to diagramming, I will look at something like this. It will look something like this. And when I do this, I'm going to ask the question, okay, so what do you expect the output to be? Instead of asking for what the output for this is, I pretend that I am trying to solve it and give them an output and confirm from my interviewer if this is the output that they want me or not. So it's your goal is to write a function that starts at the root. So I know that it will start at the root, and then it goes to counterclockwise traversal of the nodes at the edge of the tree. Okay, so I'm going to be like, okay, I'm going to do a counterclockwise, it seems like. So what will the output look like? And this here, maybe your interviewer will say the output is going to be in data in a data structure called array, right? So you have that, and now you understand what does the form of the output look like. Then it starts at the root A, then it goes counterclockwise. So you go counterclockwise G, M, F, okay? So you go to G, and then you go to M, and then you see here, it says there is a P. So are you considering P or not? So these are the questions that you keep while you're doing this. You keep asking this question from your interviewers. And your interviewers, sometimes because the question information that you're asking for, they're already in the prompt, but we kind of gloss over it. That's why it's important to kind of go through the input and output, right? So when you try to write, you say, okay, counterclockwise, it's M, and then the next one is P. And then this is not accurate. Your interviewer should say this is not accurate. And the reason it's not accurate is because we only need to traverse through the edges of the tree, okay? And P is not the edge of the tree. So that gives birth to something constraints, okay, where you usually add it to, if it is a whiteboard, you have 3 sections and you add it to one small section in the corner that's called constraints, and you add all your constraints there, okay? So the first constraint that I have is that it's in the edges of the tree, okay? The edges of the tree, okay? So what that means is that I do not include P, I include M, and then all the children, okay, and then I ask them, how is this side, right? How is this side included, which is going to be Z and W, okay? Z and W. You can ask this question, or you can ask this question, or kind of like pretend that you know it already and see what the interviewer say. So the end of the question is that you modify your output in a way that will satisfy what the interviewer say. Okay, you keep modifying your output for this input that the interviewer give you, and see what the interviewer say. Okay. So now you know what the output looks like, but it's kind of hard to understand what the input looks like. So what I'm going to do is that I'm going to give them a tree, and I'll be like, okay, let me come up with an input and see how the input looks like. So I'm going to come up with an input that looks like this. Okay, something intentionally a bit different, because I want to make sure that I cover all my bases. Okay, so let's say I'm saying my input looks like this. Okay, and I say, is this an accurate input? Is this something that you would expect? And the interviewer is going to say no, and you are going to ask why. The first thing he is going to say, or she is going to say that, okay, the values of the inputs should be characters and not numbers. And you can see here, right, the characters. So let's pretend that the other constraints that we have is it's characters, okay? And to just make it easier, we will call it lowercase, okay? So we know that the input value always have to be lowercase. And then you're going to be like, okay, I'm going to change it to A and B. Okay, is this an accurate representation of the input? And she's going to say, no, it's not. And the reason it is not is because this tree needs to be a perfect binary tree. And then we'll be like, well, what's a perfect binary tree? Okay, a perfect binary, what is a perfect binary tree? So maybe you Google it, you understand it, but a perfect binary tree is a tree where an non-leaf node has exactly 2 child, okay? So I'm gonna find the description from somewhere, including my resource, the interviewer, and I'm gonna write it down like this. It says a perfect binary tree is a tree where every leaf node has exactly 2 children and all leaf nodes are at the same level. So currently leaf nodes are not at the same level. So what I can do is that, and they don't have 2 children, right? A doesn't have 2 children. So what I'm going to do is create one for A. Okay. So now I'm going to ask, is this the correct input? And the interviewer is going to say yes. So I'm going to write the output, get approval. Okay, so far I haven't solved anything. I have defined the constraints, and the constraints are usually in the introduction if the question is really like better formatted. But the problem is that sometimes we kind of like skip over it because we think it's not important. Sometimes, for example, it's going to say sorted array, and we forget that it's sorted, and we kind of solve it for unsorted array. And it wouldn't be there if it wasn't important. So that's why you should always write it somewhere else in the constraint section. So far, we have defined an input, we have defined an output, we have defined the constraints, the first step. We haven't done anything else, okay? So the second step of the interview, which you need to spend most time at, is maybe if it's a 45-minute interview and the first 5 minutes is intro, you have to spend probably like 40 minutes on this one. And the reason we need to do that is that we want to convince the interviewer that we understand what you're doing, or you understand what you're doing. And if they are convinced, it doesn't matter what you produce or not, that's important. And the other thing that we want to do is that this also implies with defining input and output is the idea of failing fast. You want to fail fast as much as possible and early as much as possible. So all the edge cases are taken care of before you define a solution and write it down and code it and it doesn't work. And at the end, you have to debug. That is way worse than just figuring out the solution early on and see if it works or not. Lastly, it's very important that you write this area of pandemic and doing virtual interviews. Important to write your code and diagramming in the same IDE that you use with your engineer or with your interviewer. The reason is that if I have a whiteboard, which I can easily access right now, and define the solution for them or introduce and things like that. And when the interviewer leaves, they won't have access to that picturesque, beautiful drawing that you have. They won't have access to that. And when they don't, honestly, we have a lot as an interviewers, we have a lot in our mind. It's 1 hour of our day to interview is just a very small side note, right? So you won't remember all the details. That's why it's important that you do all your drawing and elaboration, all of it in the notepad that the interviewers provide for you. Okay, so that being said, those are the important things here, and I'm going to write it. I'm not going to write it down because I want to keep moving forward, but there are 3 most important things here. Okay, the good news for us is that our diagram is sort of done. We just need to figure out the solution for our diagram. So if this is our diagram, what I'm looking for is that the next step for my diagram is to figure out how to split this problem in small pieces, right? If I split this problem into smaller pieces, what I can recognize is that I can look at all the left sides, I can look at the children, and I can look at all the right sides. Okay, so now I'm going to solve only for the left sides. I'm going to solve all the bottom of the children, and I'm going to solve for the right sides. I really don't need to solve all of them together. At the end, I will just put them together. Okay. So that's a brute force scenario, and I think it will work perfectly. Later on, if we needed to upgrade the game and like build something better, we will do that as we go. Okay. So I'm gonna say left side, and then children, right side. Okay. Okay. On the left side, what I'm looking for is that if I start at the root, right, all I need to do go to from the root is left, left, and left. Okay. So there are two things that you do when you traverse a value. So in this scenario, you can talk with your interviewer about the benefits of traversing a value iteratively and recursively. Okay. So for me, I'm going to just go with the example of recursive iteration. But if you needed to talk to your interviewer about why that is, that's as fine as well. Right now, I feel like I'm not going to worry about that. Okay. So if I recursively try to iterate through this scenario, what I needed to do is two steps for the recursive process. Okay. One of them is called the action. So the action in this scenario is maybe adding the value to the array. Okay. So add current value to the array or result. Okay. And then the next step is what you need to do next. So if I add A to the current result, the next step for me would be to move from A to G, right? So traverse to left. Okay, that's all we need to do. This is called action. And this is called traverse. Traverse, okay? Okay, for the children, it's very interesting because for the children, we need to cover all these, I keep wanting to say babies. So all these babies. So what we can do is that we need to, first of all, traverse through the whole array, the whole tree. And the reason we need to traverse through the whole tree is because if I go through the left or the right, it won't cover P and the children's of P, right? For example, R, T, these won't be covered, right? So that's why I need to go through the whole tree, okay? And if the value is a child, then add it to the result. So if value is a child, add it to result, which is action, right? Let me write that down. And then the next step is the next sentence is that traverse the tree. Okay, so this is traverse. Okay, okay. The right side is kind of important because the right side is, it starts from Z, Z, W, X. So if you look at this, it goes from Z, W, X. It's the same exact thing as the left side, but it goes from bottom up. It goes from end to the top, right? So what that means is that all you need to do is do whatever the left side does, okay? And the only difference is that you need to traverse first, okay? Then you need to traverse to the right because it's right, okay? So you are here, you go here, and you go here, and then you go here. And once you head to the Z, we'll figure out how. Then you add the current value to the result. You do the action, okay? So it's reversed. Because the values are reversed, the action and traversal is reversed as well, okay? Okay. So now that we have the pseudocode, let me give you guys a kind of my 2 cents about the pseudocode. The pseudocode is important for your understanding, but it's not code. Uber and Google, especially Google, actually, Google does not let you do pseudocode at all. And Uber says that your code should be running. Okay, so you need to have a running code no matter what. And I haven't seen, unless you really impress the interviewer, if you don't have a running code, I don't think that that is a good sign for your next step. But pseudocode is optional. You don't have to do it. You can jump into the code from diagramming, but just so you know that some companies don't even allow you to pseudocode on Google. And most companies definitely prefer you to code. Okay, so if you don't have time, skip that part, but kind of like have it mentally ready. Now let's jump into the code and fix this thing. Okay, so all I need to do is what I have currently described here, and I'm going to create a function left. I'm just going to call it left. Okay, and in here I'm going to pass in two values. One of them is the result that I need, right? And then the other one is the current tree, or the current tree node that I have. Okay, I'm very comfortable doing that, so maybe I call it traversal. And for future references, let's call this thingy. Okay, and the first value that I give is the tree, which is the node at the top, and then the result is an empty array. Okay, tree is the input value that I have defined here. Okay, so according to our left side, what we need to do is to, so recursive solution have two scenarios. Okay, one of them is called, this is the only place I will define this, but then in the future we will define it somewhere else. We will use the same pattern somewhere else. Okay, in all our other recursive calls. So this is called base case, and the other one is called traversal. Okay, so when should we stop? If my current is what, I should stop. Okay, so if you look at this, if I go to current, and if my current dot left is a value, I should stop. Okay, so if you look at current dot value, if the current dot value does not exist, okay, so if I go to if, I look at the left of it or the right of it, it doesn't exist, I know that I'm here. Okay, so this is when I stop my recursive solution, and that would be my base case. Okay, so current dot left is not existent. I stop. Okay, when I stop, because I want these values of the children to be in another function, I really do not add these values in my result array. So all I need to do is to return what I have collected before. Okay, return result. Result has whatever it has. Okay, otherwise I know that I'm not in here. So what I need to do is to go through the traversal step, which is call the second guy. Okay, and on the left side. Okay, so I'm traversing through the left side of the array, and when I do that, let's actually add the value of the current. Like we want the value to be in our result before we traverse. Okay, and all I need to do is to return this guy. Okay, so if you're lucky, we are going to have all these values from here to here. A, G, M, I expect. Okay, so let's run that. The other thing that I want to do is that test my test cases, smaller test cases, and I tell them what I expect and see what I get instead. Okay, so the next step is let's find the children. Children. Okay. And then in here, I'm going to give it the tree. Okay. And I'm going to give it, let's actually call it, be consistent and call it the current. And I'm going to give it the empty array. And let's be consistent, traverse. Okay. So in here, all I need to do is to have my base case be the same thing as I have. Okay. So this is when I hit the children. Okay. when I hit the children, I'm doing this, I'm returning the value, but maybe I should add the value that I have as a child here too. So this guy goes inside the if statement. And the reason for that is because when I'm hitting here, right? The f dot left is going to be non-existent. So I'm at f and I add that value to the result array. Okay. And all I need to do is when I am, this is finished, I'm going to just call the value on the left and the right. Okay. Left. And all the result. Right result. And let's return first. Okay. So we expect this guy to send us all the babies. Oopsies. What did I do? Res is not defined. This is defined. What are you talking about? And the value. Do you guys see there?
I think on
So,
line 47.
147.
Instead
Function,
of passing empty array.
oopsies. Yeah. I didn't see res. Obviously, it's not defined if it's not defined, right? Thank you. Okay, we got it. Okay, so this is it. Blah, 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 and the next, okay. And let's, okay, because when I send, if I go backwards on this code, I cannot get it back. So let's go to the right side function, traverse, right, okay. And then the current is going to be the current, obviously, and then the other one is going to be result. Okay, so as you might have expected, all we need to do is to do whatever we did at the top for the traversal, okay, except that we change the values, okay. So this is very interesting because I needed to change from left to right. And the only reason I need to do that is because I want to go to the right side, right? So you do that same thing. This is the traversal that happens. So I'm going to push it before adding the value, which is here. So actually, I'm not going to do this. Call this guy. Before pushing the value to the result, I'm going to call this guy. This is going to be right, obviously. Okay, so traverse right. I'm adding the result. Then I'm going to push the value to the result and then return this. Okay, so look at the right, then traverse it, then add the value and then return the result. Okay, so this guy, if we did things right, will have to give a ZWA. Okay, nice. Let's put them all together and call it function counter clockwise. And this guy looks at 3. And then I have the result, which is my whole array and it's empty. First, I'm gonna call. So before I because if you can see, there are 2 values, right? One of them, there is an A here and there is an A at the beginning. So to solve that, what I'm going to do is to add the root value to the result already. So 3 dot value. Okay. Now my result array will have the root value already. So, and then I'm going to do result dot push and call the right. Call this guy on the left side. Oopsies, no, not that one. Let's do result dot push this. Okay, this is going to be left. Okay, so traversal of left is going to give me a result array, and I'm pushing that to the result, and then I make sure that I distract that value so that I don't get the double nested result. Okay, then I'm going to add the children by just having this. It's 3. Okay, traverse the children, and the value that I'm adding them is the value that I'm adding them is 3, and this is going to be actually, because we're calling it, it's going to be empty array, and I extract that value as well, and then result dot push, and this one is going to be the right side. Three dot left, you guessed it, the right. Okay, and return result. Okay, I think we get what we wanted to. Yeah. So A, it goes all the way around to W. Okay. So when you get to do this, obviously your interview is going to be like, okay, can you do it better? And you'll be like, yeah, I can do it better. Because what I need to do is I'm traversing through the whole tree no matter what. And I'm going to the left one time, and then I'm going through the whole tree, and then I'm going to the right. So what I can do is to combine them together. And the way you can combine them together, or the things that you need, is 2 values. If you have a Boolean value that always points to the left, if the current node is left or the current node is right, then you do something, right? So if I have a Boolean value that says if the value is left, that is true, and I have another Boolean value that says if the value is right is true, then you always have that. You always have that. The other thing that I know is that from the root side is both true on the left and true on the right. So because we don't have time, I'm going to go a little bit faster on this. And what I can do is to traverse. Okay. Actually, guys, do we have time to go through this? I need like 8 minutes, or we can open it to Q&A. Patty?
I think we're good. Depends on the attendees.
Okay. Would you guys, if you guys want to see the other one, please write a plus. And if you guys don't want to see it, okay. Let's see, probably a few more pluses. Okay, perfect. And if you don't want to see it, at minus. Okay, so perfect. Let's continue. What we need to do is to create a giant traversal. Okay, traversal, or what do you call it? Recursive function, and we will accommodate all of them. Okay, so I will have a function that's called traverse. This is called this system of recursive is called helper method recursion, and that's what Outco teaches very well. And the thing is that the helper method recursion has a global function that stores the global values, and inside that function they define another function that would be a bit more like the recursive solution. Okay, so I have a global function here. Let's have another function traverse. Okay, and this is going to be the function that is going to have the traversal. Okay, as we talked about this function, let's give it a current value. Wherever the node is, we want to know where your traversals are. Okay, and then we want to know if the current value is the left or the right, or both, it doesn't matter. Okay, so leftmost, rightmost, rightmost. Okay, so, and while we're at it, let's call this function. Okay, give it the tree, the parent node, and we say left the parent node leftmost side is true. So he is the leftmost side. Also, they are the rightmost side. Okay, so this is the most confusing part of the solution. I'm going to explain it again. You're saying, never mind how we solve this problem of how to send a value, but we are saying this. We are saying the current node value, which is the tree root value, we're saying it is, which is A. Okay, we're saying it is both the leftmost side and the rightmost side. It makes sense, right? Okay, charge my laptop. Okay. Okay, so when we do that, this is true and true. We're sending two values of true and it says leftmost side, rightmost side. Now let's figure out the base cases of this traversal. Okay, base case. The first one is let's figure out identify the left side. Okay, all I need to do is to check this. Okay, I'm gonna say that the base cases are, instead of doing this, because we don't have access, well, we have access to it, but we have something better right now. This was checking if you're going to the left, right? So we have a value called leftmost side. Okay, so base case, when I'm on the leftmost side, I add the current value, whatever the value is in my result. Okay, so result that push current value. Okay. Okay, and let's get rid of this. Okay. That takes care of all the left side there is. Literally, you don't have to do anything, that's it. Okay. Now let's take care of the leaves. Okay. The leaves, so this is the same thing as the leftmost side. Okay. But this one is because it's the leaves, we do it in a different scenario where we keep what we did earlier. So I'm saying if the current.left does not exist, okay, if current.left does not exist, so we know that it's child, right? You could say current.right as well. Then you add the value to the result, okay? You add the value to the result. The next thing you need to do is to get kicked out of the recursive loop. So I'm gonna just return. Okay, so as soon as I hit the baby, I put it inside the result and then I kick out of the recursive loop. Okay, and then the next one is not traversing the right. It is figuring out the traversal, because remember, traversal happens and then the right side happens. Okay, it's the action comes after the traversal because it was swapped. So all I need to do is figure out the traversal first. Okay, do you see how I solved the problem in small pieces? I just solved for the left, didn't care about anything else, then solved for the babies, and then I solved for the right. I solved for the traversal and then the right. Okay, so the traversal is this. I'm gonna call, if this is the most important point compared to the other ones, right? Call the traverse function on the, let's say, left. Okay. If I call the traverse function on the left value, I know that this is the leftmost side and that value is true, past then. Okay. But I know that it's not the rightmost side. So that value needs to be changed. That's all I need to do. If I'm going to the left, the right side is not accurate, right? It's not the rightmost side. Okay. And as you might have guessed it, that is similar to the other side. Right? Okay, I'm going to the right. I know that the leftmost side could not be true because we're going to the right side. Okay, so that's going to be false. But this one stays whatever it was. Okay, and that is at the beginning, remember, I sent true. So it keeps their value, or you can just send, you can add true here. Okay, now I have done the traversal. The other thing that I need to do is the right side, right? For the right side, what I need to do is that what I have done before already. So if rightmost side is true, you add that value to the result, okay? The push parent value, okay? So we know that that's true. You push it, and then you traverse this, and then you return the value. Okay, let's see what we get. Counterclockwise, this time I'm sending it one array here, okay? So traverse the function, traversal function, call the function here, and then return the result. All these results are saved here. Okay, so what we expect is with a little bit of modification, which you guys will know what it is, but we should expect something similar to what we have here, okay? Okay, so we have everything similar, but we have the same issue that we had before, which is A is come here twice, right? And how we can solve it is, you see, the only time that a tree has both left side as true and the right side as true is when it is at the root node. So what I'm going to say is, if this is the rightmost side and not the leftmost side, okay? So if it's the rightmost side and not the leftmost side, that's when you add it. So that will just exclude the root tree and the last section, okay? Okay, so A2, okay? All right, that is the question for today. I'm gonna send you guys the link. Thank you so much for not selecting it and copying and pasting it. Now you guys can do whatever you guys want with it. Hopefully copy it on your own ID or on another code interview page so your teammates can have access to it too. And that is it. Please feel free to ask any questions. I am gonna open the Q&A section and this one in case you guys have any questions. Oh, we don't have a Q&A. So feel free to unmute yourself, ask questions. I'm here for as long as you guys need me. No questions?
So, hi. So I have a quick question. Can you open that code again, please?
Yes.
Yeah.
Somebody has
So,
selected already. Selected? Yeah. Go ahead.
yeah. So, let me see the line number. Can you? Yeah. So at the line number 186, when we are traversing through the right side of the tree, so do you think this when we are adding that value current dot right and then false and then the rightmost, do you think this order matters? Can we write it like rightmost then false the value for that tree?
It definitely matters because that is the order that we passed in earlier in here or in here. Okay, so in line 174, we have ordered the tree. We have ordered the value. So if you want to switch it, you can just switch this value in here in line 174. The reason it matters is because we have defined it like that in line 174. If not, it wouldn't matter.
Okay. So can you explain that line once more, like how that value, rightmost value is false? Uh,
Yeah, absolutely. Can you guys unselect this? Somebody has selected and they have forgotten to unselect it, and it looks red for everyone. Somebody else also selected it. Thank you so much. Okay, so let's go back. Okay. When I am sending the root tree, a line 193, I'm saying that it is the leftmost side and the rightmost side in the tree. So if I'm sending A, it's the leftmost side and the rightmost side. Do we agree on that?
Yeah.
Okay. Then I go to line 185 and 186. Okay.
Yeah.
When I go to 185, what I'm gonna do is to say current dot left. Okay. So I go from A to G. Okay. And when I go there, I am gonna have a value. Not only I go to A to G, I also send a value that says true for the leftmost side. So what that means is, okay. So what that means is that I go to the leftmost side. It's just a value name, okay? And then I pass it the value that I had in here. I don't change the value. Remember, the leftmost side
Yeah.
and the rightmost side, both of them are true. I just don't change that value there. And then I change the other one, which is if it is left, it cannot be right at the same time, except if it is like the root value. So I change that value to false.
Yeah.
Okay. Then I do the similar thing on the rightmost side. So I traverse through the right. So I go to W, and what I send is another value that says it's the rightmost side, another Boolean value.
Yeah.
Okay. And that value determines later on if I want to change. So there is another value, invisible value here that says left or rightmost side is equal to true. Okay. For
Yeah.
each node, there is one value. So when I have that, I know that this is the next step is for me to either add the value or not based on the values. So basically, I'm adding another 2 values for each node. Does that make sense?
Yeah. Yeah. So yeah,
Thank
that's
you
why
for the
this is
question.
the leftmost value is false and the rightmost
Mhm.
value is true for that like leaf,
Yeah.
right?
Mhm. Yeah.
Okay.
Perfect.
Yeah. Thank you. Thanks a lot.
No problem. There is a question, Heidi asks, I feel like I can code this alone, but no, with no one watching. But when it's live in front of people, I freeze up. Do you have advice for this? I do the same thing. Sometimes I freeze up. It is pretty normal. So software engineering is a thing that I think women are good at, which is we admit to our faults way easily, and we are like have a growth mindset. Everybody does that. Everybody happens. The more you practice, as somebody said here, the better it becomes, and the faster you can recover from it. And that is exactly the reason why I can come up with this 4-step. I didn't come up with this 4-step formula. Outco came up, and I really, really like it. Is that no matter um, if you are frozen or not, you know these 4 steps. Okay. And when you know these 4 steps, you can conquer the world. You can just come up with those examples. You go through the same structure over and over and over again, and you're going to get good at it. And honestly, you don't have to think of a solution like 5 minutes into the problem. You're just asking really intelligent questions. You want to know what is the input, the output. You're not just jumping in the code. And even if you freeze and just walk through this, like you will get it. So follow these 4 steps. I think you'll be good. That's one advice. And the other one is obviously practice. And the other thing, I'm sorry, this is advice that is really, really helpful and has been helpful for me. And I was taking it for granted before that, was that all I needed to do was to practice one question a day. No matter rain or shine, just practice one question a day. Don't have to, if today you are super, super tired, just go with a very simple question, the thing that you have already solved, but look at code once a day. If you're not doing it already, practice one liquid question a day, and trust me, within 6 months, you're going to be a pro. Practice with people with real life, Lisa said. It doesn't matter which language is used in code. Doesn't matter. Most companies don't care about it. But if you're hired for maybe small companies, they do worry about it because they don't have enough resources. So it's really tiny startups worry about it. Almost they don't care about it. Is it okay? More generic question. Sara mentioned before that Uber doesn't accept pseudocode. Could you elaborate more on that? If I'm interviewing you, I want to make sure that your code runs. So it is kind of like interviewer have defined structure on what they see as passing a phone screen or an on-site. So it does allow pseudocode, but if all you can show is pseudocode and not code that's running, you have slimmed your chances of acceptance very low, unless you're a very senior engineer and you have impressed your interviewer pretty much out of the box, and they are super happy with your performance and it was so hard of a question. Otherwise, it'd be hard for the interviewer to justify you passing the coding challenge. So pseudocode is important, but it doesn't, that's the only thing that you can show, it's not as good as having a running code. Which language is universally accepted or mostly accepted? So I have this this LinkedIn post that I did a few days, and they're like, if you're an engineer and somebody asks you which languages, which programming languages, don't simply answer with your favorite language. Ask them what is their specialty, and then it says web JavaScript, AI JavaScript, backend JavaScript, data JavaScript. Like, anyways, I don't know if I explained the joke very well, but the point is, I really prefer Python and JavaScript because it's easier, at least for the starter. In the future, you can go back to like C++, Java. Things are gets a bit complicated, but the point of entry for you should be Python and JavaScript, at least for now. Then you can go back. Why is that? And if I respond in a programming language that is different than asked, is that okay? Is that a definite no? Why is that? What do you mean, Lucy? Why is what? Okay, I'll come back to it until Lucy responds. Is this entry level question? There is no entry level. Usually, like big companies, now that Uber kind of big companies is there's no entry level question. Like even if you're an interviewer, internships. Like when I was used to interview with Google as an internship, and now my students, when they do internship, their question is very similar to any other question. So it's sort of like an average software engineering question, not an entry level question. And there isn't any defined entry level question unless it's very basic, but usually it's the same difficulty. So it's the same difficulty level. In relation to pseudocode, you already answered that. No problem. It's no problem. Was this a real question at Uber question? I can't answer that. Yeah, I cannot answer that. Sorry. Any other question? Okay. It sounds. Do you use these questions in your life? That's a very good question. So just a little bit add to the previous question. I interview people. We interview people. All I can say is that this is the same difficulty as questions we ask at Uber. Yeah, otherwise I'm not sure how legal this is for me to tell you guys more. So that's why I cannot tell you guys more. So data structure and algorithm, I think that's why software engineering gets kind of weird, because the questions that you cover in interview is kind of, what do you say, not as good, or as relevant to the job that you do, and it has been a kind of like point of discussion for years now. This is very I work with front-end stuff mostly and React these days, and this has nothing to do with that. But the process of, I think what they want to test you is the process of problem solving. So that being said, not similar to what I do on my little day-to-day basis. If you're given a coding challenge that we have seen before online, are we allowed to use the solution that someone else shared online? Yes, but you gotta explain it like the way like you own it. Like you can share it, and so most engineers are gonna be like, okay, but some engineers are gonna be giving you a different question, or they're gonna increase the expectation once you say you have seen it before. So that's one. Second of all, you can, if you don't understand somebody else's shared online solution, do not present it, because it's not, I have had many interviews where I have solved the problem completely, like given the question and I solve the problem, don't go through the steps, and I do not get the job. And it has happened over and over and over again. Everybody knows the solution. Nobody wants to know the solution only, right? They want to know how you collaborate. They want to know how you talk. How do you come to the solution? So even if it is someone else's solution, as long as you know it better, it doesn't matter. So there's this thing, right? That this solution that we come up with, we didn't come up with that, right? People who are PhDs and I don't know, they've spent their lifetime doing or inventing these algorithms, right? We didn't come up with it. So one way or the other, it's from somebody else, right? So the point is that you're not inventing solutions here. You're not inventing algorithms here. As long as you know how to creatively solve the problem with the tools that you have, that's good enough. How many questions do they ask in the interview? Okay, good question. For the full screen, it's one question. Then it gets like upgraded, like it gets a little bit harder if you solve it easier, right? For example, like we solved it with brute force, then we were also able to solve it with another way. Excuse me. And then on site, there is at least 2 to 3 technical questions, and then 1 to 2 system design and behavior questions. Do you have to traverse binary tree etc day to day in your software engineering role? No. No. Anybody else? So you could be a really good interviewer, but you could be a really good interviewer and a shitty software engineer and still get a really good job. Okay, or you could be vice versa. You could be a really good software engineer, but not a good interviewer, and you cannot get a good job. I'm not sure if you guys have seen this question with there is this guy who invented there was this guy who invented Python or some other languages, and they went to interview at Google, and you couldn't homebrew. Yes, what was his name? And they went to okay, I will repeat it. There was this guy who invented this language or this huge library that thousands of programmers uses, okay? So I think it was Homebrew or Python or one of those. He goes to interview at Google, and then Google asks a question similar to what we did today. It was a traversing binary tree or something, okay? So it's a very similar question that we have solved today. And this guy didn't get it. And then this inventor of the language got rejected because he couldn't traverse a tree data structure, right? He was an amazing programmer, but he couldn't traverse this like data structure questions, and he didn't get a job, and he was laughing about it. So the point is that you can have very much a lot of experience in interviewing and be good at interviewing and suck at your job and or learn at your job. The better question is learn at your job and be like raise your by jumping different companies every 2 years or so, raise your what do you say, raise your like salary and things like that. Or you could be a really good engineer and not have this the interview skills. So and then you will be stuck in the same job, right? So the good thing is that we need to really hone our skills as an interviewer, because it's as a software engineer, it's gonna keep hunting you every 2 years, 3 years, whenever you need a job search, it's gonna hunt you. You cannot escape from it. That's why you need to get good at it no matter what. Start early and it's like compound interest. We'll get good at it, right? Or going to the gym, which I don't do often, but I want to. Okay. Sorry, I missed the part about the format. Homebrew. Do you mind repeating, please? Sorry, I meant, do you mind repeating about the question format? Say for L3 software engineer at Uber, what the format is. For L4, what the format is. There's no L3 or 4. There's a general questioning systems that that they ask you, and then they place you in L3 and L4. So they ask you one technical interview question, including one recruiter call and one manager call. And then you go on site, and on site there is at least 3 technical interview questions, one system design question, and one behavior/system design question. So 5 interview on site. And once you solve that, then they're gonna, based on your experience and background, they're gonna place you in different levels. Okay, this is not a negative question, about more along the line of failing efficiency. How does one know when coding is not for them? Failing efficiency. Oh, okay, coding is not for them. I question that choice every day. I think women, in general, we kind of like are perfectionists, so stop doing that. I don't know. I'm gonna just be honest with you guys. I never found that, oh my gosh, I love coding. Sometimes every day when I get stuck in a problem, I'm like, oh my gosh, I'm stuck in this problem. How did I decide to be a software engineer? I wasted, I don't know, 7 years of my life doing this. And then the next day when I solve it, I'm like, this is the best thing that has ever happened to me. And I'm so lucky to have this, blah, blah, blah. It's my everyday scenario. So you will never know. But the good thing is that we are resilient and we do it. And let's face it, the money is here. So do it. And I feel like once you do it enough, I think there's Malcolm Gladwell, there's this book that he says, once you do it enough, you're going to love it. So nobody loves a job or a thing before you do it enough that it becomes a little bit automatic. I have been I have studied in college. I have been jobless for years. I've been at Okta. I've been at Uber. It has been 7 to 8 years that I'm struggling with coding. And this year is the first year that I have started to say, I like it. Before this, I didn't do that. And the only reason I did go to software engineering is honestly because I needed the money. Okay. And now I'm starting to say, I like it a little bit. So I really, really hope that people should not stop doing coding because it's not for them, or like the cliche that they say, oh, coding is either for you or not for you. I have seen guys say that and it just pisses me off. It says, oh, you're either born with this ability or not. It's literally with like everything else. At the beginning, you struggle, and with coding, you just struggle a little bit more. And once you're done with that, honestly, you're going to conquer the world. So everybody has the mind, everybody can do it. It just takes a long time, and you just not go cry the same. Like I do this. I cannot solve the problem. I go to my manager, and my manager is like, well, you have solved this problem a few years ago. You haven't solved this problem. And I'm like, okay. And then I go cry. Like it has happened that I cry. It has happened that I'm like, okay, I'm going to quit my job. It has happened that I'm going to not look at the code for 2 days. And then the next day I clean up and then I start over again. It's life. And I feel like everybody deserves a chance to feel this spectrum of emotions and just stop saying that you do not belong in this industry. Let's see. I know that it's not a negative question. I hope I had a good answer for you, but just so you know, everybody feels the same way. Just go through this. We are resilient. We have done this before 100 times. Do it again. Just keep doing it. And one day you're going to be like, oh, wow, I did a good job. I noticed you didn't mention the time space complexity. I've heard that it's important mention in the interview. Does this matter at Uber? Yes, it does matter. Good notice. The time and space complexity in this scenario, I would have to talk to your interviewer and talk it out. There is a difference between the time complexity and space complexity, and then there is an auxiliary space complexity. So if you notice, when I changed my code from the brute force to the other side, I stopped recursing through the tree 3 times. Instead, I did it 1 time. So it reduced the time and space complexity. As long as you can talk it out, and I feel like if you can take a crash course on it and really, really understand it, because the thing is that I have done it like 7, 8 years, and I've learned that you cannot run away from it. You have to know it. So take a crash course, really, really learn it. You don't have to come up with the right solution as long as you can walk through it and tell them why you feel like it is O of n or O of n squared. Okay, and then literally walk through it and push it. You are going to be okay. So do a crash course on that. Lucy, thanks for sharing your story. Absolutely no problem. Imposter syndrome is a battle. You're awesome, and I cannot thank you enough for your time. You're smiling. Thank you so much. Thank you so much, Lisa. Are the recording available? I love there was the question on practice. That's the Patty question. The recording will be posted. Monica said that. Thank you. I cannot thank you enough. You're welcome. Thank you so much. You're welcome, guys. Guys, if you guys need to get in touch with me, please feel free to do that. It's on my LinkedIn. My LinkedIn is Sara Daqiq. Otherwise, you can get in touch with me through Outco or through any other means necessary. Just reach out to recruiters and our teams here, and they will reach out. They will contact me. Feel free to ask me any questions. I hope you guys all decide to come to software engineering field. It's a very rewarding experience, and I love you guys, even though I haven't met you guys.